So the question asks you to put up all these A, B, C. Okay, to place this A, B, C point that corresponding to the state of the gas, referring to this figure 1. Yeah, so to figure 2. Okay, so you can actually place it anywhere, but since that you need to place all of them that is have this corresponding relation, okay, because you don't need to have, because this in this figure it doesn't describe any kind of value, so you can place it anywhere in such way that anywhere the important things is you need to have the relation. So in such way, if I were to put A here, if I were to put A there, then the B should be placed somewhere, maybe here. Okay, because why? Because A and B are related to the constant pressure. And then if I were to sit, so A and B at constant pressure and B and C at constant volume, so constant volume, so C should be somewhere there. Okay, but there's a catch, because you don't, so A and B, maybe you can either put it here or there. So just, let's say you just put it there, and then since that the B and when we want to put it C, so it can be anywhere here, because it's this one is constant volume. C, this is one volume, another volume, another volume, so all the way through here is the constant volume, which indicates through this line. So you can have C anywhere here, but there's another point. There's a line here. A line here describe the isothermal line, which describe that A and C have the same in temperature. So if you look at the temperature axis here, so C currently are not at the same temperature with A. So we have the possibility of C here and the possibility of C here. Okay, here and there. So the one that intercept each other is at that point. So what you obtain here, you have the A and B relation following to this figure, and B and C and A. So right now the last one we need that C and D at the constant pressure, since that we don't have that line here. Okay, so we don't have that line here. So what are the point? How can we find a place that have this AC line together with connected with the pressure? So because we have this line, C of the possibility there, and then we need to connect with A. So if we change C instead of here, we place it there, then I can say that to satisfy this constant temperature, I can also change A there, because it's still not violate the constant pressure that share between A and B. So I can remove this whole one, and I have A and B, A and C, B are still following or condition given in the figure 1. So right now again we look at the C and D. C and D have the same pressure, but D has a lower in volume, so it will not be here, it will be somewhere there. So constant in pressure, so D can be anywhere here, that's so following the constant of pressure. But if the D going to the right side of the C, it will have the volume higher than C, which is open, so it should be anywhere in the lower volume, so which is somewhere here there. So another point, we need to satisfy that A and D should have the same volume. So this is the same volume, so if I put it D here, it will not same volume with A. If I put D there, it's not with, it will satisfy with the C and D condition, but not satisfy with A and D. So the intersection point of this line and this line is there. So you will get that the best place of D is there. So this will be your answer. That's question 3.